Okay, we are down to our last 4 examples. First of all, is there a greatest common factor? No, there's not a greatest common factor. Look at the signs and tell me what they say. Well, since 5 is positive, it's either 2 positives or 2 negatives. Since 16 is negative, that means I have 2 negatives. So if I look at all of the ways that 12 can factor, I'd either have 12c minus and c minus, or 2c minus and 6c minus, or 3c minus and 4c minus. I'd have 3 guessing frameworks. But there is an easier way to do this. If you want to do it this way with 3 guessing frameworks, that's absolutely fine. Please feel free and just put your 5 and 1 and 1 and 5 in each of those and you'll be totally fine. But if you'd prefer to do it another way that's a little easier, think of it this way. 12 is very highly factorable. So I'd have 3 guessing frameworks if I list every possible way of doing the first terms in those parentheses. But how factorable is 5? 5 isn't very factorable at all. So I could list each way that 5 factors for each of those guessing frameworks, or I could instead say, let me put 5 in the fixed spot, and then I'll just list all the factors of 12 for the first part of the parentheses. It's very, very similar to what we did before, but instead of listing all the choices for the second spots, I'm listing all the choices for the first spots, because there's only one way that the second spot can factor. So if I did this, I'd put 1 in 12. My outside would be negative c, my inside would be negative 60c. That's negative 61c, which is not what I want. Cross it out and go on to the next pair. If I put 12 and 1 in, I'd have negative 12c and negative 5c. Ooh, that's actually pretty close. Negative 17c, but not close enough. Cross it out and go on to the next. How about 2 and 6? Outside is negative 2c. Inside is negative 30c. Nope, not even close. How about 6 and 2? Outside is negative 6c. Inside is negative 10c. And I've got it. That gives me negative 16c. So that is my answer. Okay, let's go on to the next example. First of all, some things worth noting. Use the number with the fewest factors in the fixed spot. You don't have to do this. You're welcome to do it the way I kind of wrote in tiny type at the top. But for a lot of people, if you can get yourself comfortable with this, it's a little less work. Okay, next example. Is there a greatest common factor? Yes. What else do I need to do this problem? Okay, write it in descending order. And then my greatest common factor is y cubed. So I pull out the y cubed, then I'm left with 2y squared plus 13y plus 6. Okay, look at my signs. 6 is positive, so I either have 2 positives or 2 negatives, and 13 is positive, so I know I have 2 positives. The only way 2y squared factors is y times 2y. So I've got only one guessing framework, which is great, and I just list my factors of 6. Again, I have to list them in both orders. I have to list it twice because I do have a 2 in front of the y in those parentheses. Okay, now why did I just cross that off without trying it? Very good. I checked for the greatest common factor, so I know that it's safe to use the greatest common factor hint. And 2y and 6 have a factor in common. What other of these choices can I eliminate because of the greatest common factor hint? Very good, the last one, 2y and 2 have a factor in common, so I don't have to check either of those. Let's try 6 and 1. We'll put them in. Outside is y, inside is 12y. That gives me 13y, so I'm done. The only thing I need to remember to do is to make sure that I take that greatest common factor and actually put it on there. Okay, third example. First of all, some things worth noting. Don't forget the greatest common factor. Make sure you write it in descending order. And be careful using the greatest common factor hint. It's nice, but just make sure you've looked for the greatest common factor first. Okay, for this example, I do not want you to get intimidated. This is not hard. First of all, is it in descending order? Yes, it is. Remember, if I have more than one variable, a polynomial is in descending order if it is in descending order according to one of the variables. So my first term, how many m's does it have? First term has 2 m's. How many m's does the second term have? It has 1 m. How many m's does the third term have? Well, it doesn't have any. So this is in descending order according to m. Next thing I want to do is look for the greatest common factor. And you should be able to see that 10 goes into all of those. So I factor out the 10, and then I have 8m squared minus 10mp minus 3p squared. Now it's a good thing I was able to factor out that 10, because I really don't want to list all the factors of 80 and all the factors of 30. I'd be here all day long. But all the factors of 8 and all the factors of 3, it's not that bad. Now again, don't get intimidated just because there's more than one variable. Remember, just take baby steps as we do this. I don't know exactly how it factors, but I know it's going to have 2 sets of parentheses. And I know that those signs will be one positive and one negative. I'm not quite sure why I have the negative there and the positive there, but it doesn't matter as long as you have one of each. Now, what can you tell me about the variables that will go in the first spots of those parentheses? Well, they have to give me an 8m squared, so they both had better have an m. Now that's just the same as what we've done before. But now what can you tell me about what had better be in the last part of those parentheses? I need to get 3p squared, so both of them had better have a p. Now, if I'm going to say, who is more factorable, 8 or 3? Well, 8's a lot more factorable. 3, there's only one way to factor 3. So I'm going to say, okay, 3 is 3 times 1. I'm going to put that in the fixed spot and then list my factors of 8 and try all of those. If I put in 1 and 8, my outside is 1 mp and my inside is negative 24 pm. That's the same thing as mp. So that gives me negative 23 mp, which is not what I want. Let's take out that one and put in the next one, 8 and 1. Outside is 8 mp, inside is negative 3 pm, which is mp. That gives me 5 mp, and that's not what I want either. Cross it out. We'll keep on moving. 2 and 4, outside is 2 mp, inside is negative 12 mp, and perfect, that's negative 10 mp, just what I want. So my answer is the 2m minus 3p times 4m plus p, that part that I just factored, but I don't want to forget the 10. I don't want to forget my greatest common factor. Okay, we've got one more example and you're done. Okay, worth noting, don't be scared of multiple variables. They're really not that hard to work with. Here's our very last guy. Okay, now this looks deceptively easy. We have small numbers. I know that it's going to be a y minus and a 2y minus because the 2 on the end was positive, so I either had 2 negatives or 2 positives. Since 3y is negative, I have 2 negatives. So I either have a 2 and a 1 or a 1 and a 2. I can't have a 2 because of my greatest common factor hint. Try the 2 and the 1. That gives me negative 5y. It doesn't work. So what have I done wrong? Absolutely nothing. If you try everything there is to try and nothing works, all that means is that the polynomial is prime. It's just like trying to factor a number, and if nothing works, then the number is prime. But you just need to make sure that you actually have exhausted all of your choices. That is the end of Guess and Check, and we will learn some pretty slick ways of doing exactly the same thing in Lecture 24.